unexpectedly continuing the previous presentation, I would like to tell you something about the infrastructure and why I think it is really important to pay attention what is the hardware base of the implementations that you do and what is the hardware that you use to run Magento. Actually, Maciej in the previous presentation touched on several points I will be referring to. So he made a nice intro for me. I'm representing IBM, and what I want to present, or what I want to show you is a slightly different approach than the standard one, because for what I've been able to see here for yesterday, today, most of people are not really paying too much attention to where the applications are running. This is always provided by some service provider who is providing access to the infrastructure. It is practically always Intel-based server, here and there in some data center, and this is it. Yeah, there is a choice of other architectures. Just as a few words of introduction, of course, the most common in the market architecture is Intel-based architecture. Historically, Intel architecture, or x86 as we call it, is an architecture that came from the desktops, from the end user stations, and gradually became more and more advanced and became server platform. This is not the only architecture that we can see in the servers. What I would like you to present is the alternative that we want to propose. And it is based on a completely different type of processor, but it has very significant, and I would say, for what I heard here, for Magento, it could be really interesting. This is based on our processor that is developed and produced by us. It's called Power8. To a large extent, this is similar architecture. You have processor, you have memory, you have I/O, you have some virtualization engine, but there are also many differences, because historically, Power architecture has been developed from the very beginning, has been developed as a server architecture. So it has completely differently designed I/O subsystem, it has completely differently designed processor capabilities, a lot of capabilities that you use as a user or as a infrastructure providers are sitting deeply in the processor. So when you add that, when you use or exploit all the possibilities that you have on this platform, you can propose much better customer experience. That's one side. And much better or better than on x86 economics of the platform. So what's so special about Power? Currently we are at the eighth generation of the Power processor, but the key capabilities, this is just a few examples of what is different and what can be used to build great performing and economically performing platform to run your applications. One of them is simultaneous multi-threading. Each core of the processor can run at the same time, can run 8 hardware threads in a single processor cycle. Which means that if I have 10 processors in a machine, I can run 80 threads at the same time. Compared to only 2 threads of the Intel. This is really great advantage in all the applications that are easily scalable into threads, which is typically Java, which is typically transaction processing, where you have a lot of small transactions which can be dispatched to different processors or to different threads within the processor. That's one great advantage. We had just a few moments about different bottlenecks. One of the bottlenecks was the memory. Look at the bandwidth of the memory subsystem of the Power servers versus the Intel servers. This is very visible in highly utilized, in highly memory-dependent applications. So whenever you have an application that uses a lot of RAM, and generally recently most of them are using a lot of RAMs, this advantage will become visible in day-to-day operations. Another one is general approach to caching, 4 levels of cache, intelligent caching of the data, of the processes, and especially of the data that are being accessed. This is also improving time to get and process data, which is then visible at the end, at the very end of the process. It is visible as the responsiveness of the system. And one very, very important part of this system design is the virtualization approach. In general, on most, if not all, hardware platforms, you can see that virtualization is additional software layer that is added on top of the hardware. So you have the server, then you add on top of that VMware or some other virtualization software, and this is software. This is additional layer that is put on hardware. In the power architecture, the virtualization is embedded into microcode of the server. This is hardware embedded virtualization. One big advantage of that is that we can have a lot of additional functionalities that we cannot get on other platforms, but the biggest advantage of that is that it has completely no performance overhead. So when you compare implementation of a specific application on Intel-based servers with VMware, you can always observe, and I think that any of you who implemented things like that observe that VMware is really taking up resources and is really visible and across different applications. We can see that in the databases, we can see that in the commercial applications, and I'm pretty sure it will be the same effect in the Magento implementations. VMware will simply eat up the resources, which means that it lowers the economic effectiveness of investment in hardware. Virtualization in power is hardware-based, and it simply is invisible. So whatever resources you have, whatever resources you assign to user, they can use it in full amount. And one additional, completely different story is as we call it, RAS features, so reliability, availability, and serviceability. So all the features that decide or define how reliable and how unbreakable the system is. Most of them, or many of them, are to bigger or smaller extent embedded into the chip itself. They also sit in the microcode, etc. I will be covering that later on. So on the hardware level, we have several things that really differ in these platforms. And at the end of the road, so from your user perspective, are visible as better responsiveness and lower overall resource requirements. We can have the same work done on lower number of cores, lower number of memory, because of the effectiveness of the platform. So from the economic point of view, this is interesting. That's the hardware. One other interesting thing about this hardware is you can see the Open Power logo here. This architecture, we have decided to open this to the community 3 years ago. We have founded Open Power Consortium together with Google, Mellanox, NVIDIA. Initially, there were 5 companies. Right now, it is almost 100 companies working around this platform, mostly in software, by the way. This platform is right now, I think, the most open hardware platform that you can see in the market. But the whole openness actually comes down to the great effort of many companies, not only IBM, but I would even say mostly outside companies, to optimize, create, develop a software. So when Maciej was saying about optimizing bottlenecks at each level, I would say there is a lot of optimization available on Power architecture that is not really available on other platforms. And it starts with the hardware, this is also, let's say, hardware layer, where with Mellanox we are optimizing the data processing and the data transfer between the components of the system, and mostly between the processor subsystem and disk and data. But then you have all the software stack, and what we have created together with our community partners is so-called Turbo LAMP stack. Of course, everybody knows what LAMP stands for. We have optimized at every level components that are used by many of the open source or Linux-based applications. Magento is one of them, but we are not limiting only to Magento. So, for example, in the system, operating system level, you have an optimized version of operating systems that are compiled to take advantage of all the hardware capabilities that the system has. And you have choice of Red Hat, you have choice of SUSE Linux, Ubuntu. These are the three main. But there is also Debian. There is also all derivatives of these distributions. So depending on your preference, you can use different version of the different distribution of the operating system, having all the hardware capabilities enabled in them. Another part is Apache Web Server. For what I've heard here yesterday, most of the Magento implementations actually are based on Nginx. Nginx is also available on this platform. Then the database, and MariaDB is just one of the examples, but in general we have done some testing with MariaDB, with EnterpriseDB, with Mongo. Most of them turn out to run roughly 2 times faster on the same resources, 2 times faster than on Intel-based servers. So if we are talking about the bottlenecks, if we are talking about the optimizing, this is a good place to start. This is good way of optimizing the access to the data and overall effectively optimize the customer experience from running Magento Shop. And then we have PHP. In the traditional or this well-defined Turbo LAMP stack, PHP is done together with Zend. And I think it has biggest impact on the overall performance of the applications running on top of that. But this is not only about performance. Zend is optimized to use all the capabilities of the Power Platform, but at the same time Zend is providing some other stuff, especially Z-Ray, which is, I think, quite interesting for developers because it lets you take a look at at how PHP code is executed, what resources it's using, and where are the bottlenecks. So, to some extent, Zend gives you tools to also take a look at the PHP code and see if there is some low-hanging fruit or easy optimizations that you can do to have your code running faster. I'm providing links here. You can read about details of that. In general, what we want to do is more or less what Maciej said. We want to optimize the stack from the very hardware level, for the deeply in hardware, starting with processor, all the way up to the application itself. Now, of course, because we have created an optimized stack, we wanted to test it. So you can find on YouTube, and the link is down there. You can find a movie or a short video, 10 minutes video, presenting results of the comparative test of Power versus Intel. I will not be showing you this video because it's, I think, a bit too long, but just a quick view, what has been tested. We just assume the scenario that we have two providers. One provider is putting the application, the Magento application on Intel. Second is putting Magento application on Power servers. You see components here. Generally, the idea was to build the system as comparable as we could to have the result of this test meaningful. We have prepared a special small mobile app that that we use to simulate the workload and to measure the results. And we based on Magento performance benchmark to see how actually those two platforms behave and what is the effectiveness or the performance of each of them. So what we've been able to observe. This is a bit technical, but this exactly shows you the thing I told you about the simultaneous multi-threading. Both machines were configured with 5 cores. 5 cores. So on Intel, you can see the upper window on Intel. This is the 10 virtual cores or 10 threads that Intel is running. At the same time, on Power, you have 20. Yes.
What was the processor type on Intel?
The processor type on Intel on the test was, I think, Haswell.
Haswell, but what family of Haswell?
I can tell you, but I think this is shown in the video. So if you take a look at the full video, you will see. Yeah. The test was run, I think, somewhere in the middle of last year, or I don't know. The video, I think, was published in October. What you can see here is one thing: you have much larger number of simultaneous threads in the Power platform. At the same time, you can see that Magenta is actually a good example of an application that is really able to use it and to saturate all the threads. Yeah. Now, the test was run for 2 minutes, and within these 2 minutes, we wanted to achieve at least 90% of response times below 2 seconds. Yeah, that was the main idea of the test. The results are here. One other thing that was visible during the test was that after a short while, when we started to increase the workload, Intel processors started to overheat. And they started to throttle down the clock speed. And because of that, actually the average transaction time, what you can see here is the result for the Intel, and this is the result for the Power. So Intel could process roughly 60 transactions per second, Power could process 70 transactions per second, with much better average transaction time. And overall, the number of transactions processed in the 2-minute window was much larger on the Power platform, which basically means that you can either have similar configuration and put more workload on that, or you can just configure less resources and still be able to satisfy the customer requirements. And this is again economics. As I said, the full video can be seen on the YouTube, so anybody who is interested can take a look at that. And that was the performance part of the story. Of course, in the e-commerce world, another part of the story is the reliability. And again, because Power was from the very beginning designed as the server platform for the greatest reliability, it has zillions of features that are generally created to or designed to keep the system running. And a lot of features are just available on Power. Many of them are taken from the most reliable platform in the world, which is mainframe, and most of them are not available on Intel. So for example, if you have several processors in the system and the processor fails, typically you can get system kernel panic, you can get system down, everything is shutting down. On Power platform, the processor will be deactivated, the traffic will be redirected to other cores, and the machine will keep on running. Same stuff about memory. If memory DIMM fails, the system is deactivating the memory and is able to keep on running. And it is all about keeping running. Even if you have lower resources for a moment, you are keeping the traffic and customers are still able to access the applications, the customers are still able to work, even if response time goes slightly up. There is a long document summarizing the features, description of how they work. It doesn't make sense really to go one by one with them. So here's the short link for this white paper if you want. I think this is really nice reading because it shows how many things you can do just in hardware, and it happens automatically, so you don't really have any administrative overhead on that. How many things you can do just by choosing the right platform to keep the system running and to keep the system to keep the clients working on the application. And this is generally it. If you are talking about the brief, let's say, introduction to the Power architecture, as I told you, this is, in my opinion, this is a very interesting, very viable alternative to Intel. From the performance perspective, but also from the economic perspective, because better performance, better reliability actually translates into better economics in the end. And because I'm from IBM and this is IBM platform, so maybe I'm not really the most objective guy. Just to finish the presentation, I will just show you a 2-minute video from one of the Magento developers and what he says about the Power 8.
Magento Enterprise Edition is a platform, an e-commerce platform. Magento is famous for being an extensible platform, which means our developers can come in and have full access to the code and develop those really innovative experiences that merchants need to stand out in a very crowded e-commerce market. Our merchants are always looking for a performant, scalable architecture that allows them to add new servers to meet peak demand. The clients that will be most impacted with Power 8 are Magento Enterprise Edition merchants. These are small to mid-size, sometimes up even to enterprise class clients that are trying to scale their businesses to match the pace of growth that they're seeing in time for holiday season. The ability of Power 8 in terms of more memory utilization, in terms of higher peak loads, is absolutely going to help solve Magento 1 and Magento 2 performance and scalability issues by allowing us to handle higher workloads on the storefront in terms of page views, in terms of traffic, and higher workloads in terms of our checkout, in terms of the number of orders that we receive per hour and per second. With Power 8, one thing we can say is that our independent testing has proven that the Power 8 architecture can deliver a 2.5 to 3x performance improvement over similarly priced Intel architectures using the IBM Turbo Lamp stack. One of the key benefits of Magento is that it's based on open source software. We have a community edition that we make freely available to anyone who wants to download it, and that's where the innovation starts. And on top of that, we create our Magento Enterprise Edition, which is our licensed software. We're very excited that IBM is leveraging both open standards and Linux platforms and core principles that Magento holds near and dear and has allowed us to fuel our growth and add the innovation that's in the community. The partnership with IBM allows Magento Enterprise Edition to scale up to even larger levels. It allows us to access new clients that are at even higher tier than we were able to achieve before. So it's really going to allow us to scale our business up to get a whole new class of merchants in, true enterprise class merchants.
Thank you for your attention. If you are interested in the topic, I will be here for some time. Happy to discuss. Please use internet, use web, use Google, use YouTube. There's a lot of material on that. And just additional information, because all the data I presented here are just coming from the world. We wanted to have our independent view, so we started to prepare the test with our colleagues from Centuria. Hopefully they will run fine, and hopefully they will prove same or better results than we could be able to see here. Thanks.